Hello. Good evening, everybody. Let's get some music on. And some bird screams.
Greetings.
Okay. So, yesterday I engaged on the quest of figuring out quests. It wasn't a very good stream, but it was a stream. And the streams are happening daily, so anyway. Yeah. Spent some time thinking about how quests are organized in games and how they're laid out and what they're supposed to be able to do. And the result of this was essentially this. That the game system has some kind of entity that represents a quest, which defines a description of the overall quest to do for the player to read. And it has a starting task that is initiated when the quest is started. And then each task defines another minor description of what to do next. Some kind of arbitrary trigger that defines when the task is completed. And then which tasks to spawn once the task has been completed, if any. And then also which kinds of interactions to add or remove from NPCs and items to actually facilitate doing the task, if such interactions are necessary. The task can have 4 states. It can be unresolved, which is the standard state. It can be completed successfully, it can be failed, or it can be bypassed in case there are multiple ways of fulfilling a quest. So the quest gives you multiple tasks, and you can choose one of which to complete, so that if you've done one of them, the other ones become obsolete. So maybe obsolete is a better description. And then, I don't know why the syntax highlighting screws up, thanks Emacs. Anyway, and then you have the actual interactables, which are NPCs or items that the player can interact with in some fashion. And those simply have a list of interactions that are currently possible, which is consulted when the player initiates a conversation, so to speak. Okay, so that's it. As far as I can figure, this is the most general and most strict definition for a quest system that I could think of. I haven't had much time to think about this today because I've been extremely busy. Been busy playing games, I've been busy making cookies and cooking dinner and entertaining guests and so many things. So I didn't have any time to think about this by myself. So this is still the same state as yesterday.
Times are busy.
I don't know about that. Best kind of busy is a productive busy where I'm writing code and making lots of progress. But that was not today. Anyway, so then we went on to make an example using a textual form, and that quickly proved to be hard to understand because the connections between the actual task items are very loose, and so it's quickly very difficult to understand where the flow of the quest is going to go and how things are related to each other. So I am of the opinion that a textual representation for something like this is not feasible. It is feasible for a dialogue itself, which is typically not laid out in a complicated graph kind of fashion, but rather pretty linear or linear descent with minor amounts of branching or, looping or whatever, and also in a very local kind of context. But for the quest system itself, once you have branching tasks, it becomes very, very difficult to figure out how things relate and where they go and how you can get things done, and whether they're mutually exclusive or complete or sound. So what I would like to do instead is define this in terms of a flowchart graph. And flowchart graphs are, well, I don't know what the proper mathematical term for it is, but it's not a graph. Not by typical definitions, or at least not by definitions I know about. A mathematical graph is defined in terms of nodes and edges, nodes having a certain number of edges going to other nodes, and these edges can be directed, so they can have an input and an output. But difference between that kind of graph and a flowchart graph is that there's no way to distinguish sort of what kind of outgoing edge an edge is. So all edges are just outgoing edges, and if you want to sort of distinguish that, you need to have an intermediary node. So you need to have one node represented as multiple nodes, where each input and output kind is another node within that. And that gets really annoying, so instead of dealing with that, I've designed a library that's whose purpose it is to deal with exactly that. So kinds of flowchart graphs where the inputs and outputs are assigned to discrete ports that have a semantic meaning. So this library is just called Flow. It's in QuickLisp, it has some docs. And I've used this library for a couple of things before. For instance, in trial it is used to represent shader passes or pipelines. So each shader pass has a number of inputs, which are textures it needs to draw, and a number of outputs, which are frame buffer targets that it creates. And you can connect these outputs and inputs together in an abstract graph kind of fashion, and the system will use this information to automatically allocate the optimal number of textures required to perform this drawing operation. So yeah, I've also used it in the Harmony sound library for a very similar kind of purpose, where you can string together sequences or graphs of sound processing steps, and it'll figure out the optimal number of buffers to allocate. Okay, so in this case though, we're going to use the library not to do any kind of optimization work, but rather to simply present this kind of information in a more tangible manner. The code itself that we're going to write today is still going to be very abstract, so it's not going to be anything that would help this problem in specific, but rather we're going to hopefully use this definition that we're going to outline here to later build a user interface that displays this in a nice flowchart kind of way, so that you can drag nodes around and you can edit them and connect them together how you want. So that's the goal. That's the idea. Okay. Right. So let's have a look at the Flow library. README for that. Okay. Right. I've created a new directory and a new system and package and whatever, so that we can have this separated from the rest of the game until we're done with it. So, and then similar to the dialog system, we'll hook it up later. So for now, this is completely separated. We're not dealing with any other parts of the game system. Okay. So first of all, I need to define what kinds of nodes we have. So we have a starting kind of an overall graph of nodes is going to be a quest. So the quest is going to be just a collection of nodes grouped into what Flow calls a pipeline, I believe, or does it call it anything? No, it doesn't call it anything. Okay, so we're gonna have a class called a quest, which contains a number of nodes. Make array 0. Okay. And we're gonna have a node called a task and a node called an interaction, or an interaction, not an interactable. And the task is going to be our primary node. Pretty much the entire graph is going to be made up of tasks and interaction snippets. The interactions being dialog parts that are initiated or added and removed to interactables. Okay, so right, flow, define node, task. Okay, each task is going to have a number of causes and a number of effects. I guess. The causes being possible tasks that spawn the task, and the effects being possible tasks that completing the task will spawn. Okay, so this is going to be two different kinds of ports, both being endports, meaning that you can have an arbitrary number of inputs, or connections rather. Okay, so let's first define the ports. Let's just call it, yeah, causes, flow, import, flow, import, and effects. Also, hello to number 3 and mintbots in chat. Okay, so we're gonna have causes, port type causes, and effects, port type effects. Okay. Now, each task is also going to have a completion condition, so I guess just call it, no, I don't want to call it condition because that clashes. Let's call it, or let's call it condition. Package, need to shadow that. Right. I have no idea what that chat message was about. Okay. The condition will tell us whether to advance or not. Then we're gonna have a description. Or let's actually make a superclass for both of these. Describable, which can have a title and a description. Or let's make this a string. Okay, and the task is also describable. Oh, whoops, I'll remove that. Okay, what else did we need? A state. So here comes the first kind of question, which is that when we have this description in this kind of graph format, then we're not going to need to represent runtime states necessarily because we're just designing it. But we could use this graph format for runtime as well. meaning that the system is going to use these nodes that we defined directly in order to, you know, evaluate things at runtime. Or we could do something very similar to what we've done with the dialog system, which is to say we use this information to compile to something else that will be more convenient for our system to deal with. At this point, I'm unsure what to do, which of the two would be better. It would definitely be simpler in terms of implementing the system to make everything at runtime, so that we don't need to write another compiler and worry about all that kind of stuff. But it might be advantageous to have a compiler, both for efficiency, but also for fault checking and stuff like that. So I don't know yet. Yeah, so I'm gonna leave that out for now. Now, aside from the causes and effects, which the task has as in and out ports, we're gonna have certain ports that define invariants that need to be fulfilled. Meaning that if this invariant is failed, then the task becomes unfulfillable, meaning it's failed. So we can model that as another field here, invariant. So the invariant condition tells us whether the task is completable at all, and the condition tells us whether we've completed a task. Okay. A task will automatically be marked as obsolete if another task in the same breath has completed its condition. Or rather, if we reach a new task that's going to be activated, then all previous tasks that are not marked as completed will be marked as obsolete. Did the music just stop? Why? What the fuck happened? Told you to fucking shuffle. Asshole. Alright. Okay, and then we have a node for an interaction, which has, as we said, it has an entity it attaches to, so an interactable. And a dialog. And then we have another port. F-class interactions. Flow and port. This is neither an input nor an output port because there's no direct flow of information between them, they're just associated. So we're gonna add another port here. Interactions, port type interactions. There we go. Okay, so this defines the basic layout of our flowchart, meaning the kinds of types of data we have and the types of input and output ports that they have. Actually, this is gonna need another port as well for the tasks. So port type. So or maybe we should call it maybe we should call this triggers. So that we could also add other snippets to be executed on when the task is done. Yeah, let's do that. And then tasks. So let's do flow, define node, trigger, which has that, and the interactions that trigger it. There we go. That's better. Okay, so that defines the basic data layout, I guess. Additionally to this, I want to define some validation, which ensures that we can't create any invalid flowcharts that make no sense. So for this, we have a couple of functions which are not listed here, unfortunately. Holy shit, my birds are pissing me off. That's something I say every night, but my god. Why always when I stream? Why couldn't they just be quiet when I stream and be more angry otherwise? I would be completely fine with that. Okay, right. So... So for the causes port and the effects port, we just need to check that the thing on the other side is a task as well. Or actually, we need a special kind of node which denotes the beginning of the quest, and also the end of the quest. So let's add some nodes for that. Find node. Start. Or actually, we could define the quest as a node, which is the starting node. Yeah, no, I don't like that. Right, so... Oops. Start has a thing, and... causes.
Tell Burp hi.
Tell him yourself. Look at him go. It's really going at it. It's so weird watching them with the video desync, because the audio is not quite the same.
Word. Hi, BIRB.
Alright. That's the bird check for tonight. Okay, check type. Flow. What is this? This is the causes, right?
I broke my physics. The balls never stop bouncing.
Oh man. Oops. And here we need to check the right part, which needs to be a task or the end. Port effect. Okay, for the triggers. Actually, that should probably be an in and output after all, because we are pointing towards those. Yeah. Flow input. Okay. Check type flow right needs to be a trigger, and also we need to check the right as well. Okay. There we go. Yeah. Needs to be a task. And for that, the direction is opposite. No, actually, shouldn't. Huh. No, never mind. Should be fine if I do it different, so... Or task trigger. We don't want to use... Ugh! Left of the connection is a task, then right, needs to be a trigger, or vice versa. Or let's do an E type case instead, because that sounds better. Oh my god. I'm gonna turn off the lights. Sorry, I can't deal with this. Okay. So now the flowchart should be checked properly. That all the information makes sense. Good. Right, never mind. Let's not do that.
I fixed it.
Nice. Okay. Message from before is bothering me. Sorry, what? I still don't get what that guy meant. Anyway. Okay. Right. So the next step is actually putting this information together. So I'm gonna put this down there. So I want to add some convenience functions to string this stuff. Let's see. So, if I remember this correctly, now the way this actually works through the mop is that even though these slots here are defined as sort of ports, you can still read out the connected nodes through a standard accessor. So let me test that real quick. Let's make instance task title A and B make instance task title B, and then we flow connect the port of A called effects to the flow, port B causes. Okay, and then we should be able to see causes or effects of A. No. Value of flow connection is effects, which is not of type or task start. What? Oh, right, that's a port. I'm a dummy. Need to node it first. Because, yeah, a port itself can also contain information. So, getting the left or right end of a connection is going to give you the port itself rather than directly the node. So need to resolve that properly here. Okay, yeah. Oh, it gives me a list of connections, okay. Right. So this is sort of an example now. We made two tasks, A and B, and I connect the effects of A to the causes of B, and that means I have now a connection between task A's effects and task B's causes. Yep, as specified. Actually, this is a double-ended connection, which I don't want. Yeah, so let's also add a check for that. Check type connection flow directed connection. Okay, and for this it should be an undirected, but they can't really do that. This is fine. So this is gonna get an error, yep. Okay, so now we get a one-sided connection. Good. I'm still not gonna do this through the direct reader because I don't want to return connections. I want to return the actual nodes instead, so we're gonna define some handy accessor functions to deal with that for us. Okay. So causes, task, map car, node, slot value, task, causes. Oh, node. Alright, whoops. Effects needs to be... Ah! Or... So that should work. Yep, now we get the actual task on the other end. Good. Okay. Triggers. Okay. Yeah, the lack of weight in physics simulations is, it's a struggle. Because, making anything that's forward kinematics interact with a physics simulation is really, really challenging. Or in other words, because, you know, the player character you control is not actually a physical object as determined by the physics system. It sort of gets force out of nowhere, which means it has infinite amounts of strength, meaning that when objects interact with it, all the collision system can do is sort of just, you know, take it as it is and launch it, because there's no feedback on the player model. Like, you don't want to get bounced backwards by a crate or something like that, because that will be annoying. So yeah, there's games out there that have tried to, like, properly incorporate the player character as a physics entity, but those are real goofy as well. For entirely different reasons. But yeah, it's just how it is. It's hard. Okay. We should probably also call this... Nah, this notes is fine. Tasks. Probably call this... do we need a list of nodes at all, or do we just need the start node? Could do just a start node.
I only heard half of what you said because my kid is loudly complaining about someone killing him in Fortnite.
Oh my god.
I'm sure your speech was lovely.
Minty, you are living the hell. Okay. What would be a good name for a function that strings two of these tasks together? I guess cause will be connect, I guess. Cause task.
Chaining.
Yeah, I'm just gonna call connect like it is in the flow library itself, I think. Or chain, nah. I don't know. Right. Okay. There we go. So now we have a more handy function to connect these together. So instead of using this lengthy thing here, I can just call connect AB. And that will be the same. Let's also add a print object thing. There we go. Yep. Okay. It would probably be good to compile this into something more useful or more convenient than dealing with it directly. Maybe. I don't know. I'm in this. I can't decide on this right now. I don't have enough insight. And I really hope we can play Age of Empires with Minty, but I don't know if her connection is going to be stable enough. That might be an issue.
It'd be great.
It would. Okay.
What? Repeat that.
Oh my god. I hope we can play games with you, but I don't know if your connection is gonna be too shit or not. You can, by the way, you can just seek backwards in the stream, you know. It's a YouTube video, you can go backwards yourself and fucking watch it again so I don't have to say it again. Okay. Right.
Ooh, that's what I thought I heard. I do that and I risk shit being Jack.
Problem is I can't really do much more with this system as it is right now without making this decision, because anything else about it would be about
So long
further
as I'm not
processing of
downloading
things.
anything, the game should be stable.
It's more about the latency, because you might be in a too remote of a location to have a stable connection to us. That's the problem. I don't know. It's an old ass game, so it should be optimized, but I genuinely don't know. Well, actually, never mind. For the Steam version, they completely rewrote the network stack, so I don't actually know if it's still as optimized as it used to be. Okay.
I've been saying that for a while here, and Sucky'll still be like, why is your internet so bad? And it's 'cause there's like 12 people here.
Okay. Alright, let me try to iterate or expand upon what my current problem is. So I'm debating whether I want to use this direct graph representation for actual execution during the game. So when the game is running, it somehow needs to know, you know, which tasks are currently in flight, which are going to be activated, which are going to be, you know, completed and when, and, you know, what are the descriptions of the tasks and quests currently in flight, and things like that. And also, you know, when are interactions added or removed, and all of that kind of stuff. So either I could define the system as operations on these nodes and ports and things like that, or I could have another step that extracts the useful information and puts it into a format that's actually more usable for the game itself. The problem with the former is that it might get quite complicated to extract the information at runtime and quite cumbersome to do so. And the problem with the latter is that it's a bigger system to implement. So I don't know. I also don't know with the latter what exactly it would involve doing. So I'm not sure which to pick right now. But besides defining these data structures, there's not really much I can do, because all that's left is the operations on them, and that's exactly what I'm unsure about. But I need to be sure about this to do anything.
Would it be a huge workload to change from the simpler later?
it would essentially involve rewriting everything. So, yes. Or at least I imagine it would involve rewriting almost everything. I can't make up my mind. Okay, so if I did the compilation thing, what exactly would that look like? Is the question. I need to know in order to be able to gauge how difficult it would be to implement such a compiler. Or let's think about what the system needs to know at runtime in order to do things. So, or rather how the system might proceed at runtime in order to do stuff. So, let's say the player goes up to an interactable thing. So, player walks up to interactable and presses interact. Okay, check list of interactions on interactable and present choice. If interaction chosen, execute interaction or execute chosen, and that's it. Okay, and then we also need to have for if any kind of story relevant event happens, which is sort of difficult to discern right now, but on story event, let's, oops, on a story event, go through list of tasks. For each task, check if where is it? Right, invariant violated or invariant violated. Mark as for each active task. Invariant violated, mark as failed. If condition passed, mark as succeeded. Mark as failed, remove from active tasks. Condition passed, mark as succeeded. Activate all successor or effects tasks. Form. Whoops. Okay. Yeah, okay. Activate all affected tasks. Of affected tasks, mark all other cause tasks as what is it called? I had a term for this. What was it? Obsolete. Okay. Yeah. Or let's do it like this, for all affected tasks. Mark cause tasks as obsolete. Fuck. What was it called? If end task, mark quest as complete. Move, or, yeah. Otherwise, activate task. Okay. Sorry, mosquito. Okay. Is there anything else that's required?
If a cause task has other effects, should it still be obsolete?
That's an interesting question. That is a very interesting question. Yeah, if you have deep branching. Huh. I guess not, right? Unless... this is an interesting one. So, if the new task that is about to be activated, if there are no successor nodes for which the current node is not a predecessor, but the predecessor task is one, it should not be marked as obsolete. Otherwise, it should be. So in other words, if the path from the predecessor node to the end node is always going through the current task node, then it should be marked obsolete, otherwise not, because there might be another way of solving the entire quest. I think that's an accurate algorithm. But yes, very, very good note. Thank you very much for that. That's very good. For all, mark all cause tasks for which the current task is the only is required among is in the only path to the end node as obsolete. Mark all cost tasks that are unresolved and for which the current task is in only path to the end node. Okay, that's quite a sentence and a half. But yes, I think that should be correct. I don't have a proof for it, and I'm not going to make a proof, but that sounds and seems correct to me. Yeah, one simple consistency check we could do here is to always check that each task necessarily resolves to an end node. Though, I don't know, maybe you will want to be a dick and like offer tasks that don't actually lead to a solution of the quest. I don't know. In either case, that's something for later. Okay, is there anything else we need? Well, move from for all affected tasks. Okay, move from otherwise activate tasks. A task and activate all triggers. Anything else that we need? I guess we do need a list of active quests as well, and alongside a list of active tasks. Just, you know, because you're probably going to want to offer a quest list and things like that. Though you could also have just a quest list sorted by completion. Just probably what you want. Instead, I think this is correct. Yeah, it seems this has been a problem throughout this so far. It's just it seems too simple, almost. It seems deceptively simple. I don't know. Okay. In any case, right.
Deactivate all triggers when deactivating task.
That's the thing. You might not always want to do that, so I would like to leave it in the hands of the trigger to deactivate itself if necessary. So the trigger has the job of removing itself if it is one that should be removed. You might want interactions that stick around even after the task is complete. For instance, you might have like a quest that ends in, going back to our cat example, like the cat lady might thank you for it at the end, and you might want that interaction of her thanking you to just stick around indefinitely. So you can, you know, whenever you go back to the old lady, she says, thank you for saving my cat, you know. So in the case where interactions should be removed, I think that should be defined in the interaction itself, rather than just being removed immediately. Of course, you can also have something like, I don't know, a sticky bit that tells the system whether to remove it or not. But I don't know. I don't know too many things about this. Or rather, there's too many things about this that I don't know. Sentence structure in English is a challenge, isn't it? Okay. So as far as I see, the information is already conveniently enough stored in the node representation so that there's no need for an explicit compilation unit. The only kind of problem I see where compilation is required is when you actually edit this kind of graph, then you would want to have invariant and condition and the dialog as source rather than as compiled information. And since there's no way to go, you know, both ways, I can't just decompile. So I think I still want a separate representation, but one that is extremely similar to this. So let me Let's define another file, maybe runtime, I don't know. Or, nah, not runtime. Let's call it quest.list. And we're gonna have quest in here. And we're gonna have a list of tasks. And a list of active tasks. And we're gonna have, well, I think I'm gonna put these into a different package, so let's do that. Quest.graph, I guess. Local nicknames. Oh my god. Okay. Ah! Hmm? Okay, right. Let's actually put these before... No, I can't put them before the ports. Never mind. Oh well, that's fine. Package. Delete package. Okay. 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 Spicy. What? Okay. Oh. Oh. I was in the package still. No bueno. Okay. Okay, before I reload things, let me just... I don't need that. Let me quickly define the necessary classes that I want. So I want a traction, which has a, well, essentially this, but I'm gonna call it dialog and assembly. Okay, have a good day, Minty. Okay. And I'm still gonna add it superclass. And we're gonna need a task as well. Scribable. So this is gonna have a number of causes. That's triggers, variant, mission. And in this case, these are going to be compiled things, so actually, let me call it dialoguing after all. Okay. There we go. We're actually not an accessor at all. Reader. There we go. That should be it. I don't need a representation of the start and end nodes. I can just represent that otherwise. It's fine. Okay. What do you mean? I guess I haven't loaded things yet. That's why. Okay. Error. Why? Describable is not external. That's fine. Let's fix all of that up. Describable, typo, description, pauses, effects, triggers, tasks, task, invariant, condition, trigger, interaction, interactable, dialog, start, end, and connect. There we go. Now you'll be fine or not. Right, condition is still. There we go. Good. Okay. Alrighty. So let's work on translating these. Should not have an inner arg at all. Let's call these effects as well for consistency. And you're gonna pass it a start node. Okay. Check type. Off start. Wait, no quote. Alrighty, so this is gonna go through do list or set effects quest. Do we need a list of tasks? Yes, we do. Yeah. Slot value quest effects. Transform start. Should tasks be a list? No. Should be a hash table, probably. No. Should be a list. Okay, I need to think for a second. Tasks. Okay. Should probably put that in here instead. That's fine. Okay, so how are we gonna do this? Right, we're gonna keep a hash table that associates graph tasks to actual tasks and vice versa, so that we can keep check whether we've already translated them or not. I'm gonna call this cache for lack of a better word. Cache table test EQ. And no. Do list for transform start cache. And then at the end we're gonna return effects and the tasks. So effect in effects start. And okay. All right. So now we can use a generic function to dispatch and what we want to translate. So task hash. And actually each get method, we can do the cache check in an around method thing or get hash thing cache setup get hash thing cache call next method instant memoization. Okay, nodes. Okay. Make instance task. Transform. Whoa. Okay, handy trick. Alright, and then we need to file form. Okay, that should take it for the task. Death Moth. What was it? Interaction. Just call this that. There we go. Whoops. And dialog we need to actually compile, so I need to pull in the dialog system. Okay, and that should be everything. So this does a pretty trivial translation into these different classes that have compiled properties. So based on this, we can now write methods that actually put into practice this here. Okay. Oh wait, I forgot the describable things. Whoops. There we go. And yeah, for the interaction, I'm not quite sure yet how to do that. Probably needs to be provided by the gameplay system itself, because it needs to know how to retrieve an interactable and how to attach the interaction or the dialogue to it. So I'm going to leave that open for now. Let's define a generic function though, which is going to activate the thing. So for the quest, it's quite trivial. You just call navcar activate on all the effects of the quest. Also, we actually need a backlink to the quest itself. So that needs to be provided in the transform. So I need to rewrite this. Okay, that should be enough. Right. Activate. Alright, we also need a status. It's arg status. Your status. That one can actually be changed. So the status can be that. Good. Right. Def method active p. What did we say it was? I forget every fucking time. unresolved. There we go. Okay. So... Right. So... So now we need to go through the list of causes. And do the check. When active the task. Then we need to check whether this is currently the only task along the node to the end. When and active required task. Wait. Status. Okay. All right. Let's also make a thing. Let's just do it like this instead. Whatever, man. Oops. There we go. Maybe I should make this. Nah. Shouldn't be a thing. Hmm. Let's see. Probably import those actually into the package. Package. I should probably actually make that into a function too. Sort tasks. There we go. There we go. That's much better. Okay, so this should ensure the invariant that a task that's unresolved is in the active tasks list, and this should ensure the invariant proposed by this. Okay, now we complete the task. Then mark as succeeded. Move from active tasks. Okay. Then okay. Also, this is wrong parent stuff. Okay. Right. Check task. Task. Or maybe I should call it try task instead. Uncall. If the invariant does not return true, then we call and set status as, or let's make this into a cont. And there we go. That should be this. Okay. Okay. So, if I did everything right, this should be now... everything. Or close to it. Do I need the task list? I guess it would be good to keep it around. Active tasks. Yeah, okay. Yeah, I think this is it. Looks like I need to learn CL. This looks like a lot of fun, says Pat in chat. Yeah, CL is a lot of fun. It's the most fun I've ever had programming. And I've done a lot of programming. It's no exaggeration to say...
This is turning out really fun to use.
It's no exaggeration to say that learning Lisp, Common Lisp, has really diminished the amount of enjoyment I get out of doing programming work in any other language. There are some things that other languages, of course, do better, but overall, yeah. Tried learning Erlang last month, and I went through an entire book and just didn't do anything with it. Oh well. I just kept instead thinking about ways of doing the same thing in Common Lisp instead. My mind is poisoned. Alright. Yeah. So, yeah. Actually, the start and end aren't yet represented in this, so hold on. If method transform interaction or end of end. So what would it be? Activate defect, right? I guess I can have an end marker that's... Actually, since we don't have a container for the quests themselves yet, there's no way to remove them from the active list of quests. Or add them to it once they're activated. There's also no way currently, that's another thing, serializing this entire information into a save state. So I think we need another class to hold this stuff. So def class, let's call this, what we call this, container for the quests, for the entire story stuff. Environment, storyline? Storyline I don't like because it implies there might be multiple storylines, which doesn't really make sense in this context. Or maybe it does. Does it? I don't actually know. Maybe it does. Let's call it storyline. seems the most apt. Quest, active quests. And another. Reader. Or let's make that an accessor. There we go. And then you need to link back to the storyline. Pat is saying I'm currently learning Haskell, but I just don't get productive at it. Yeah, Haskell is it's interesting for you know, the different perspective and semantics and stuff it presents. But I couldn't find myself using it either, outside of what I had to do. Yeah. Okay. Or maybe we shouldn't call this active quests, but rather known quests. Because you probably still want to know about quests even after you've completed them. So, probably still have a status. Ah, blech. Need to reload everything afterwards. Are you having connection problems, Pat? Right. Probably call this. Yeah, let's add a function. Sort quests. Sort. Otherwise, Oops. Wrong thing. There we go. Okay. Alrighty. In order to set it to inactive, it has to be currently, or in order to set it active, it has to be inactive first. Equal inactive. And in order to set it to there we go. Should probably also add a check like this to the task. Okay, status. No, let's call it complete to stay consistent. Unresolved, failed to complete. And what else was the state? I forget. I passed, I believe. No, obsolete. Okay. Alrighty. Typically, I don't write a lot of checks like this, but here it seems very appropriate to have things rigorous. To the degree that we can make it rigorous in any case. Okay. Okay. Yeah. Alright. Yeah, once active. Also need a complete thing. It's also add some generics. Try task. Or let's yeah, let's just call it try. Okay. Yeah. Where is it? Try task. We can add a try method on that as well. Setf status quest. Actually, it can be complete or failed as well, I guess. If you have no more paths to completion, then it's going to be failed entirely. Right. What else? Yes. What else did that complete method do? Thanks for the honk. I know it's almost time. Well, a few seconds it's gonna be time. That's fine, okay. Where is it? Setf active tasks to nil and return the quest. Okay. One last thing, the end thing I haven't mapped yet because guess I'm just gonna add a shim class for that. Where is it? Task class end, which just has the quest. If method activate and complete quest end. Okay. And then here we map that, make instance. There we go. Okay. Yeah, okay. So that's, I guess, the outline of the data structures and behavior of the quest system done. Quest system, data structures, and behavior. Fuck! What am I typing wrong, please? Probably one of those. Okay. Right. It's this, I guess. Okay, so next time, tomorrow, it's gonna be either it's going to be either tying this into the game system already or writing a sort of a visualizer for it that allows me to build these graphs in a UI one of those two, I suppose. Unless there's something else that needs to be done that I'm forgetting about right now. But I don't know. I'll have to think. But yeah, so that's it for tonight. Did some very basic stuff, but I hope it was entertaining anyway. But yeah, tomorrow might be a bit more interesting than this. I hope so anyway. Alright, thanks everybody, and have a good night.
Thanks for the stream.
Sure.